Section 3.1, Graphing Linear Equations, Day 2. I would not view this video if you have not done the worksheet from Day 1 in Section 3.1, because the lesson today in Day 2, we're going to go through every single one of the problems from the worksheet from 3.1 Day 1. So I would do that worksheet first, and then you'll use this lesson as a way to correct your worksheet. Our essential question for this lesson is the same as it was yesterday. So how do you determine if an equation represents a linear or nonlinear graph? Remember that a linear graph is a graph that makes a straight line. A nonlinear graph is a graph that does not make a straight line. If you do not have your worksheet out already, get it out now. You'll notice that this first problem, y equals 3x minus 1, is number 1 on your worksheet. Alright, so I'm going to put my 5x values into my table. Remember, we want 2 negatives, 0, and 2 positives. So I'll always do -2, -1, 0, 1, and 2. Then I'm going to take all of these numbers and plug them in to my x. So 3 times a -2 minus 1. 3 times -2 is -6. -6 and -1 make -7. Think of these as both being negative, the 6 and the 1. So I'm going to put the -7 under my y column. Then I'm going to plug -1 in for x. 3 times -1 minus 1. 3 times -1 is -3. -3 and -1 make -4. 3 times 0 minus 1. 3 times 0 is 0. 0 minus 1 is -1. 3 times 1 is 3. 3 minus 1 is 2. And 3 times 2 is 6. 6 minus 1 is 5. So now I have all 5 of my coordinate points, and I can graph. So the first coordinate point is -2, -7. So go over left -2, down 1, 2, 3, 4, 5, 6, 7. -1, -4. 0, -1. 1, 2, and 2, 5. So you'll notice that these red dots make a straight line. So it is linear, and it is a function. Number 2 on your homework is 2x squared minus 5. Again, I'll put my x values in, -2, -1, 0, 1, and 2. 2 times a -2 squared minus 5. Now you've got to think hard about this one. We know we have to do PEMDAS, so you've got to think about, what do I do first? Well, PEMDAS has parentheses first. I've just got the -2 in my parentheses, so there's no more simplifying I can do there. Then it's exponents. So -2 squared is like -2 times -2, which would be a +4. Bring down the 2, bring down the -5. 2 times 4 is 8. 8 minus 5 is 3. So that is my first y value. Now we're going to plug -1 in, so 2 times -1 squared minus 5. -1 squared is like -1 times -1, which is +1. 2 times 1 is 2. 2 minus 5 is -3. 2 times 0 squared minus 5. 0 squared is 0 times 0, so 0. 0 times 2 would be 0. 0 minus 5 is -5. And I'll do 2 times 1 squared minus 5. 1 squared is 1. 1 times 2 is 2. 2 minus 5 is -3. And lastly, 2. So 2 times 2 squared minus 5. 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. Now I'll graph all 5 of those coordinate points. Negative 2, 3. Negative 1. Negative 3. 0, negative 5. 1, negative 3. And 2, 3. This makes what we call a parabola. A parabola looks like a U. So this one is nonlinear. And is it a function? Does it pass my vertical line test? Yes, my green line is only touching my black line one time for each line. Number 3 on your worksheet, 4 over x. Now this one you've got to think about a little bit. If we do our normal negative 2, negative 1, 0, 1, and 2, that will work except for one of the numbers. If you don't know which number it's not going to work for, you'll see when we get there. So I'm going to take 4 and divide it by negative 2, which would be negative 2. 4 divided by negative 1 is negative 4. 4 divided by 0, is 4 divided by 0, 0? Well, let's see here. If I put it in the calculator, you end up with a divide by 0 error. So that means there is no answer for 4 divided by 0. So we don't want to use the 0 in our x values this time. We're going to have to pick another one. Let's keep going. So 4 divided by 1 would be 4. 4 divided by 2 would be 2. Now we want 5 coordinate points, so we've got to figure out one more to add to our table. What else would divide nicely by 4? We could do negative 4, or we could do positive 4. So 4 over 4 would make 1. Now we have 5 coordinate points. So if you ever end up with one that doesn't work out nicely, you got to add another one that would work. So negative 2, negative 1, negative 4, 1, 4, 2, 2, 4, 1. Now you might be a little bit confused on what shape these make, and that's okay. Don't connect all the points. This one actually makes a shape that looks like this. So one curve, and then another curve. So we've got to answer our questions. Is it linear? Does it make a straight line? Nope. Would it pass the vertical line test? Well, this is always slightly curving. Other one's always slightly curving. If it's always slightly curving, then it would pass the vertical line test. All right, now we have absolute value. Negative 2, negative 1, 0, 1, and 2. This one's simple. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So that one was quick. Graph those 5 points. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. This one makes a V. Y equals 2 to the x. Okay, this one's a little tricky. So I'm going to put my 5x values in. So if I have 2 to the negative second power, you're probably thinking that the answer is negative 4, but that's not quite right. Negative exponents are actually kind of tricky. Put negative 2 or 2 to the negative second in a calculator if you have one. you'll notice you ended up with 1/4. If you have a negative exponent, you're always going to have the 2 squared would be 4, so that's how they got the bottom number. And then you'll always have a 1 on top, so it's always going to be a fraction. I don't really want to graph a fraction, so I'm going to get rid of these 2 negative exponents. Let's start with 0. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And then let's add a couple more positive values. So 2 to the third power is 8. And 2 to the fourth power, remember that'd be 2 times 2 times 2 times 2, so 32. Oh, sorry, I multiplied that wrong. I was thinking 2 to the fifth. That would be 16. Okay, so let's erase these. 0, 1, 1, 2, 2, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 4, and then 16 would be somewhere up here. So you'll notice our line is close to being straight, but not quite. It makes this gradual curve. So it would be nonlinear and yes. The important thing to remember on one like this is that you don't always want to use those 5 values. If you end up with numbers you don't like fractions or decimals, change your x values. Really, you can pick any that you want to. We just always try to do a couple negatives, 0, and a couple positives. But if those negatives don't work out or those positives don't work out, pick new ones. All right, x to the third power, -2, -1, 0, 1, and 2. So -2 to the third power is like -2 times -2 times -2. So -2 times -2 is 4. 4 times -2 is -8. -1 to the third power, -1 times -1 times -1. -1 times -1 is 1. 1 times -1 is -1. 0 to the third power would be 0. 1 to the third power is 1. And 2 to the third power is 8. So you'll kind of notice a pattern on that one. We have -8, -1, 0, and then +1, +8. If I graph those, -2, 1, 2, 3, 4, 5, 6, 7, 8. -1, 1, 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So that one looks like a smooth curve. Is it linear? Nope. Is it a function? Yes. Square root. All right. So if I do -2, -1, 0, 1, and 2 for square roots, think about what happens if you take a negative square root. You get an error. So we don't want either of these. What about the square root of 0? Let's see here. If I take the square root of 0, I end up with just 0, so that would work. Square root of 1 is 1. Square root of 2, I end up with a decimal. So let's not use that one, and let's find another nice square root. Square root of 4, that's nice, it's 2. Square root of 5, no. Square root of 6, 7, 8, 9 is a nice square root, it's 3. 10, 11, 12, 13, 14, 15, 16 works, that's 4. So you'll notice this pattern here, 1, 2, 3, 4. 0, 0, 1, 1, 4, 2, 9, 3 would be over here somewhere, or down here a little bit, 16, 4. So this one is a slow curve that looks like that. Linear? Nope. Function? Yes. And the last one, 1/2 x plus 3. -2, -1, 0, 1, and 2. If you don't know how to put a 1/2 in your calculator or a fraction, you can always think of it as 0.5. So 0.5 times -2 plus 3. So if I think about if I have half of -2, that would be -1. -1 plus 3 is 2. Half of -1 would be -0.5 plus 3, so 2.5. That's a decimal, but you know it's not too bad of a decimal. I'm going to leave it. If you wanted to pick a different number, you could. Half of 0 is 0. 0 plus 3 is 3. Half of 1 would be 0.5. 0.5 plus 3 is 3.5. Half of 2 would be 1. 1 plus 3 is 4. -2, 2. -1, 2.5. 0, 3. 1, 3.5. 2, 4. And you'll notice that one is linear. So is it linear? Yes. Is it a function? Oops. Yes. It is a straight line. All right. So the big thing we want you guys to get out of this lesson is looking at equations that were linear and nonlinear. So I would still have your sheet in front of you. Look at your equation with 2 to the x. Did that one end up being a line or not a line? It ended up being not a line. 3x plus 1, that one was a line. Square root of x was not a line. Absolute value, we don't have the plus 2 in our equation, but we had absolute value. That was nonlinear. 1/2 x minus 3, that was the last one we just did. That was linear. 4x squared, we didn't have this exact problem, but we had exponents. Exponents are nonlinear. We had the 4 over x, so a fraction with an x on the bottom. That's nonlinear. This one makes a straight line, so it's linear. This one is curved, so it's nonlinear. Parabola is nonlinear. This v is nonlinear. And this straight line is linear. So I want you guys really to pay attention to what's nonlinear. So exponents are nonlinear. Absolute value is nonlinear. Square roots are nonlinear. Fractions with a variable on the bottom are nonlinear. Everything else is linear. Another click and drag. So this would be just dragging all the equations. I'm not going to do all of them, but I'll do some. So exponents are nonlinear. This one doesn't have exponents, square roots, absolute value, fraction with a variable on the bottom, so it's linear. Linear. Fraction with a variable on the bottom is nonlinear. Linear. Exponents are nonlinear. Absolute value is nonlinear. Fractions with the variable on the bottom are nonlinear. Exponents are nonlinear. Exponents are nonlinear. So there you kind of get the big picture. If you see a fraction with a variable on the bottom, exponents, absolute value, those are all nonlinear. I want to show you one more. This one is a fraction, but a 4 is on the bottom. That is okay. It just can't be a variable. What does a linear equation look like? So it looks something like this. Nonlinear would be square roots, fractions with a variable on the bottom, absolute value, and exponents. How do you determine if it's a function? Vertical line test. And that is it for this lesson. There is no homework for this lesson.